Yesterday we looked at how to solve systems of equations graphically and with a table. Today we're going to look at how we can solve them algebraically. And the first method we have is called substitution. We want to use this method when we have one variable that can be isolated easily. And we start off by solving one of the equations for that variable. Looking at our first example, we have two equations. In the second equation, we have a positive y and a negative x. When we solve for a variable, we always want to solve for the positive version. So it's going to be easier to isolate y instead of x in this case. This means for our first step, we're going to go ahead and add x to both sides. And we're going to end up with y equals x plus 1. Then our second step says we are going to substitute the equation from the first step into the other equation. Here is our other equation, the one that we haven't used yet. We can start off step 2 by rewriting the other equation, which was 4y equals 8 minus 4x. Now this is where the substitution comes in. In step 1, we said y is the same thing, or it's equal to x plus 1. That means we can replace y in our other equation with x plus 1. This now will become 4 times x plus 1 is equal to 8 minus 4x. We'll make sure to distribute the 4 to both terms, so 4x plus 4 is equal to 8 minus 4x. Then we can add 4x to both sides, and we can subtract 4 to both sides, giving us 8x is equal to 4. Then divide both sides by 8, and x will be equal to 1/2, or we can write that as a decimal of 0.5. This gets us now to step number 3, where we have solved for one of our variables. Step number 4 tells us that we need to plug our solution from step 3 into one of the original equations to solve for our other variable. Let's choose the second equation, which was y minus x equals 1. Now we'll replace x with what number we know it is, and y minus 0.5 will equal 1. We can solve for y by adding 0.5 to the other side, and y will equal 1.5. Lastly, for step number 5, we are going to write our answer as an ordered pair. Remember, with ordered pairs, the x variable comes first and the y comes second. So we'll have 0.5, comma 1.5. Or we could write these as fractions, 1/2, comma 3/2. Either way will work. We now have our solution, but we can always check our answers to systems of equations. To do the check, you're going to plug the solution into both of the original equations. Our first equation was 4y equals 8 minus 4x. We'll replace the y with 1.5 and the x with 0.5. So we have 4 times 1.5 equals 8 minus 4 times 0.5, which gives us 6 equals 8 minus 2, which comes out to 6 equals 6. We know our first equation works. Let's try the second one. The second equation was y minus x equals 1, so 1.5 minus 0.5 does in fact equal 1. Now we know for sure that our solution is correct. With the second example, we're going to start off the same way. We want to decide which equation has a variable that's easy to get by itself. In the first equation, we have this negative y, but that would require 2 steps to get it by itself, since it's negative. In the second equation, we have a positive x. In order to get x by itself, all we need to do is subtract 8y to both sides, and x will be equal to 10 minus 8y. That is step number 1. Go ahead, pause the video, and practice doing the rest of the substitution method on your own. Remember, you have all the steps listed above that you can use to help you follow the correct process. After the substitution, you'll end up with y equals 0. It's okay to have a solution of 0. 0 is a number and can work in our equations. Then we can plug in 0 into either equation. I chose the second one. And we'll find that x is equal to 10. So our solution is 10, 0. Doing a check confirmed that that is the correct solution. Another method that we have is elimination. With elimination, we want to line up all of our like terms for the equation, meaning our x's are lined up on the same side, the y's are on the same side, and then all of our whole numbers are on the opposite side of our equation. Step number 1 here is already done for us. Step number 2 says we're going to look for opposite coefficients that will eliminate one of the variables. And if you can't already, we're going to make some by multiplying the entire expression by whatever number is needed. Looking at our equation, we have a negative 1y and a positive 1y. If we add those together, they're going to cancel each other out. So that means step number 2 is also done for us. Now we can add the rest of our variables. 2x plus negative 3x is negative x. 9 plus negative 15 is negative 6. We'll divide by negative 1, and x will be equal to positive 6. This finishes out step number 3, where we've solved now for one of our variables. From here, it's just like what we did with substitution. We need to plug our solution back to an equation to find the other variable. Let's plug into that second equation. So we have negative 3x plus y equals negative 15. We can replace the x with its solution, 6. So negative 3 times 6 plus y equals negative 15. Negative 18 plus y equals negative 15. We'll add 18 to both sides, so y will be equal to positive 3. Here is our second answer. Now we'll combine these together in step number 5 with our x term first, which is 6, and y next, which is 3, meaning the solution is 6, 3. Then we should get in the habit of always doing a check. We'll plug our variables into both equations. The first equation is 2 times 6 minus 3 equals 9. 12 minus 3 equals 9, and this one does check out. Second equation, negative 3 times 6 plus 3, does that equal negative 15? Negative 18 plus 3 does work as well. So now we know for sure our solution is 6, 3. In the second example, all of our terms are lined up. We have our x's and our y's on one side and our numbers on the opposite side. Now we're ready for step 2. We need to try to cancel out either the x's or the y's. It doesn't matter. Let's pick the x's. We have negative 4 and negative 5. We need to find what's a number that both 4 and 5 have in common. That would be 20. Then one of them also needs to become positive so that they'll cancel each other out. Let's multiply the top equation by a negative 5 and the bottom equation by positive 4. We need to make sure to distribute and multiply each term by the negative 5. This will give us 20x minus 25y equals negative 5. We'll also distribute the 4 to all three terms to get negative 20x plus 28y equals positive 20. Now from here, we are ready to cancel out our x terms and solve for y. This is getting us ready for step number 3, so finding the first variable. Go ahead, pause the video, and finish the rest of this elimination problem. The solution to this problem is 6, 5, and when we check, we do know we are correct. Sometimes you'll be asked to solve a problem using one method or the other, and sometimes you get to choose. So how do you know which method is best? In example A, we already have x, which is solved for. So in a case like this, substitution would be great. We can take 12 minus 3y and plug it in for x in the second equation, which means we have 2 times 12 minus 3y plus 6y is equal to 24. Go ahead and distribute. 24 minus 6y plus 6y equals 24. Simplify, our y's cancel out, and we have 24 equals 24. We're going to notice we have no variables in this case. Since this statement is true, we're going to have an infinite number of solutions. Relating this back to what we did yesterday, This tells us that these are going to be the same line, which is also what we called a dependent system. In the next example, all of our terms are already lined up for us, which means elimination might be easier. If we want to cancel our y terms, 2 and 4, we can multiply the top equation by a -2 in order to make it become -4. We'll distribute, and we'll get -6x minus 4y equals -20. We can add it to our second equation, where our y's cancel out, and we'll actually notice our x's cancel out as well, and we'll have 0 is equal to +10. This statement is not true, so we're going to have no solution. Relating this back to what we did yesterday with systems, this would mean that we have parallel lines, which is considered an inconsistent system. So now we've looked at some examples where we have solutions, where we have infinite solutions, and no solutions. If the variables cancel and each side of the equation is equal, then there will be infinite solutions. But if the variables cancel and the sides of the equation are not equal, then we will have no solution. Lastly, we'll use substitution and elimination to solve a problem. Let's say that a music store offers piano lessons at a discount for customers buying new pianos. The cost for 6 lessons and a one-time fee for materials is $300. For 12 lessons and the one-time fee, it costs $460. What is the cost of each lesson and the overtime and the one-time fee for materials? Let's start off by looking at what are we asked for. We want to know the cost of the lesson, and we want to know the one-time fee for materials. This means we'll have to find two different answers. First, though, let's define our variables. That way we can write some equations. We're talking about lessons, and we can say that lessons is represented by L, and we have that one-time fee for materials. We'll just call those materials and represent it by the letter M. Now we're ready to write our equations. A tip for writing equations is to look at what is your total? What are you trying to write the equation about? Going to the second line, it tells us that the person is going to be paying $300. So that's one of our totals. But what do they purchase in order to reach that $300? Well, they have 6 lessons, so that would be 6 times L, since that's how many lessons they took, and they had that one-time fee for materials. So we're going to have to add M, our cost of materials. Let's look for our second total. Well, the other option could cost them $460. And again, what do they have to purchase to get up to $460? That is 12 lessons, or 12 times L, and that one-time materials cost. So we'll add M. Step number 3, we're going to use substitution, or we can use elimination to solve the problem. Doesn't matter. In this case, since the variables are already lined up, elimination might be a little bit faster. We can multiply the top equation by a -1, make sure we distribute, and we would end up with -300 is equal to -6L minus M. Now we can add that to our second equation, and our M's cancel out since they have opposite coefficients. That leaves us with 160 equals 6L. Go ahead and divide both sides by 6. And we're going to get that one lesson is the same thing as 26.67. That is how much it cost to get one lesson. Now that we know one variable, we'll plug it back in to find our other. So we'll have 300 is equal to 6 times 26.67 plus M. That means 300 is equal to $160.02 plus M. Then we'll subtract 160.02 from both sides, and the cost for materials is $139.98. Now we know that each lesson costs $26.67, and the one-time fee for materials is $139.98. We've already done a lot of checks in this lesson, but remember, we can always check by plugging this back into the other equation to ensure that we have the right answer.